Okay, so we are just reviewing factoring. There's seven different types of factoring, and then after the review, you're just going to do 7 of the same type of problems. So you're going to do 1 of each on your own. That's it. That's all we're doing today. Yes? And then this unit has lots of factoring in it, so that's why we're going over this. So our GCF only problem is going to look like this. So you'll notice the problems are not on there for the notes. We're going to do this problem. Oops. So what is my GCF? 4. So I'm going to always look at your smaller number. Does 4 go into 24? Yes. So I'm going to take out the 4. Now, what else do they both have? An x. Now, this one has 2 x's because this is x times x, and this one only has 1. So what can I take from both of them to be fair? Just 1. So this is just x. So 4x is my GCF. And when I take that out, what do I have left? Well, the 4's cancel. And remember, with dividing, you subtract. So 2 minus 1 is 1. If this is positive. 24 divided by 4 is 6. And these x's cancel. So does x plus 6 break down any further? No, so there's my answer. Now, you will see sometimes a trinomial, which is 3 terms, be a GCF only. So if you ever take out a GCF and then the middle is prime, that means it was a GCF only, and you'll write it like this. Yes? Okay. Okay, look at trinomials. I know it says snowflake, but we did the box. I'm actually going to shove 2 problems in here. So the first problem, we're going to write small. Because I want to remind you, I've seen lots of mistakes with when A is 1. So when A is 1, well, first things first, don't ever tell me A, B, or C, or X. If y'all ever tell me that, I'm going to cry. So please don't do that. So A is 1, B is 3, and C is negative 10. Remember, if there's no number, it's just 1. Also, be very, very careful and pay attention to your negatives. Okay, we have A times C on top and B on bottom. So what is A times C? And what's B? 3. What multiplies to give me negative 10 and adds to give me 3? Backwards. Positive 5, negative 2. That would have given me negative 3. Now, when A is 1, we do not have to do the box. That's why it's different. We can just build our parentheses. We know x times x is x squared, and we can bring down our split b. So plus 5 minus 2. And there's my answer. Do you remember that? For when A is 1. However, if you do the box, you should still get the same answer as long as you did it correctly. So now when A is not 1, we have problems like this. It's a K, but if you write X, that's fine too. So when it's not 9K squared plus 66K plus 21. So first things first, we should always check for a GCF. Does it have a GCF? Yes. Okay, always start with your smallest number. Does 9 go into 66? No. So it's not 9. What else goes into 9? 3. Does 3 go into 66? Yes. Does 3 go into 21? Yes. However, if you were unsure, remember you could do math, write 9 comma 66. Remember, you can only type 2 at a time. And it tells me 3. Well, 3 does go into 21, so I know 3 is my GCF. However, they do not all have letters, so I can't take out a letter, so it's just 3. And I have to divide it out. And that leaves me with 3k, not cubed, sorry, squared, plus 22k plus 7. Now, I am going to bring that 3, I'm going to write it over here so I save room. I'm going to build my parentheses, and I'm going to cross off that GCF so I don't let it mess me up. But I already wrote it with my answer, so I know that I'm good. Okay. I also am going to cross off what was given to me to begin with lightly because I don't want to accidentally plug that into my box because I have to do the box on this one because A is 3. So A is 3, B is 22, and C is 7. A times C is 21, B is 22. What multiplies to give you 21 and adds to give you 22? Now everything's positive, so I know it's going to be two positive numbers. So do y'all remember the trick in the calculator? You could do your top number divided by x, top number divided by x plus x, yes? And then go to your table, and you look for the bottom number, which is 22 and y2. Look, there it is. So my numbers are 1 and 21. Yes? What goes in my first box? 3k squared or 3x squared if you'd rather use x. And what goes in my last box? 7. Okay, this is where I saw lots of mistakes, people accidentally putting the b term in that last box. So then your split b goes in the opposite too, so plus 1k, plus 21k. And then remember, you'll always have a letter here and here. This is positive, so that's going to be positive. This is positive, so that's going to be positive. Like if this is negative, you put a negative, and if this was negative, you put a negative. So whatever's there is what's going to go there. Now, that doesn't tell you anything. So here I always look at my smallest number. 1 is my smallest number. Does 1 go into 3? Yes, so 1's my GCF. Find my smallest number. Does 7 go into 21? Yes, so 7 is my GCF. If you weren't sure, could you have used Math Right 9? Yes. Does 3 go into 21? Yes. And does 1 go into 7? Well, 1 goes into everything, so yes. So do I have to put this 1 in front of my k? So there's my answer. Okay, so now let's do one that's prime. So I'm telling you it's prime. Obviously, during your work, is it going to tell you that it's prime? No. Okay, so I'm going to pick one of small numbers, which is pretty easy to obvious that it's prime. But it's not always going to be that way. So when it's in order, no GCF, and can't factor, prove the square root of b squared minus 4 times a times c is not a pretty number because we added the square root to it. So if it says error or has a decimal, it is prime. Okay, so normally right here you would try to find your A, B, and C. What's A? What's B? And what's C? And you would try to do your X. Well, the only thing that multiplies to give you 4 is 1 and 4 and 2 and 2, which will never add to 3. So that's why this is prime. But to prove it on problems that it's harder to prove with the X, you're going to use this. Now, when you're doing what we're doing in this unit, you don't have to actually prove to me on paper that it's prime. So you're going to be factoring things like this and trying to break it down to cancel things, yes? Maybe not on that one, but like you're going to try to be factoring to cancel things. So if it's prime, you just won't factor it. Does that make sense? But sometimes it might look prime and it's not prime. So this is just what you would use to determine if you couldn't tell if it was prime or not. Yes? So here, you don't ever have to do it on paper. You would just do it in your calculator. It would be 3 squared minus 4 times A times C. And when I type it in my calculator, I get error. It says non-real, so it's error, which proves to me that it is prime. Okay, any questions with that? Okay, let's look at difference of squares. We like difference of squares. They are usually pretty simple. Okay, with difference of squares, remember we always want to write it as what squared minus what squared. So we can find our A and our B. So what squared gives me 4?
2.
And then what squared gives me C squared? Well, just C, right? Don't ever forget your letter. If it has a letter, make sure you bring it down. What squared gives me 25? 5. So what's A? 2C. And what's B? 5. Now I want you to realize this step is just this step. These are the same. And then this that I just underlined is what tells you your answer. So 2C minus 5, 2C plus 5. Now is it okay if you wrote 2C plus 5, 2C minus 5? Yes, it doesn't matter the order. If you wrote plus first and I wrote minus first, it doesn't matter. Yes? Any questions with that? Okay, so this is our grouping problem. Grouping is when you have 4 terms. So grouping is when you have 4 terms. What's wrong with my grouping problem?
You put it all out of order.
It is all out of order. So what's it going to look like in order? What goes first? 4x cubed to the third power is going to go first. So 4x cubed, then what? So the squared, so plus 2x squared, then what? Minus 2x minus 1. So now it's in order. Now, does anybody remember what we do first in grouping? We have to group it. How do we do that? So we would cut it in half. Do y'all remember that? And find the GCF of both sides. What's the GCF of the left side? 2 is the number, and then this one has 3 x's, and this one has 2, so how many do they both have in common? 2, so we have to take out x squared. So what's 4 divided by 2? And then we subtract, so 3 minus 2 is 1. Plus, what happens when everything cancels in division?
1.
It equals 1. Perfect. Now, when my first term equals a negative, what do I have to take out?
A negative.
A negative. And does this have a GCF?
1.
A 1. So we're going to take out negative 1. Y'all, when you divide by 1, does that change anything? No, but the negative, all that does is cancel both of these minus signs. So this just becomes 2x plus 1. Now, who remember what has to happen in this step? Does anybody remember anything about these parentheses? What do you notice about ours?
It's the same.
They're the same. They have to be the same. Or you did something wrong, or it's not factorable, okay? Which is also a possibility. So here, because they're the same, that's our GCF, and we have to take it out. So I wrote it down because it's my GCF, and I took it out. So when I take it out, what do I have left?
2x minus
2x squared. Be careful, don't forget your squared. Minus 1. So there's your 2 factors. Okay, 2 more. Bear with me. Hmm? Yeah, on the back. Okay, so here's our sum of cubes. So cubes is a lot like squares, but in squares we wanted to figure out what squared minus what squared, but now we want to figure out what cubed plus what cubed. Well, what cubed gives you x cubed? Just x. So a is x. And what cubed gives you 27? 3. Now, y'all will be able to use those yellow papers. Somebody stole mine last period, so I don't have it. But a is x, b is 3. Now, on this one, it is super simple, again, to skip that step where we show our work when it comes to cubes. I'm going to show it on this one. I won't be mad if y'all don't show it on the simpler ones. However, if it was a problem like this next one we're going to do, I won't be super happy if you skip the step. Yes? Okay, so here we have a plus b first, because we're going to plug it into the answer. So a plus b, and then we have a squared minus a times b plus b squared. So all I did was plug in my a and my b without simplifying anything. But like I said on this one, would that have been easy to simplify in your head? Yeah, because x squared is just what? X squared. That sounds like a trick question, but it's not. Okay, what's x times 3? 3x. And what's 3 squared? 9. So this one would have been pretty simple to just go from here to here, and you probably could have skipped that showing your work step. However, if you look at this next one, is that one going to be as easy to do without showing your work? Don't look at me like that. No, it's not. So you do want to show your work on this one for sure, for sure. So the only difference between sum of cubes and difference of cubes is literally, if you look at your symbols, this one has a minus at the beginning while this one had a plus, and then that second symbol again flipped. That's the only difference between them. Okay. So again, what cubed, but this time minus what cubed? Well, what cubed gives you 64? No, that's squared. 4. Okay, and then do y'all remember what we did when our exponents didn't match? We're going to put an exponent in there, but how do I figure out what exponent? Math for sure. What kind of math? Not subtract, divide. So what's 9 divided by 3? 3. Because remember, here is parentheses, so that means power to a power, which means multiply. 3 times 3 is 9, so now these are equal. 5 cubed is 125, and again, 6 divided by 3 is what? 2. So A is 4m cubed, and B is 5n squared. Whoop. And now this one is one of those ones where it is super important to show your work on that step that I said you could probably skip on that one, because it will get confusing real quick. So that first step is 4m cubed minus 5n squared, so a minus b. And then it's a squared plus a, and I'm going to use a dot for multiplication, times b plus b squared. I know this one's gross to end on, but it's not that bad. Oh my gosh. You might. I don't know. Your hand might fall off. Okay, now this is the important part. So when you square something that has a coefficient and a variable that has an exponent, you have to give that, because it's parentheses, you have to give that squared to everything on the inside. So what's 4 squared? 16. And then you multiply, because this is power to a power. What's 3 times 2? So m to the 6th. Plus, well, here you multiply. What's 4 times 5? Now, m and n are not the same, so they can't combine. So we're just going to write them in alphabetical order. Plus 5 squared is 25, and then 2 times 2 is 4. There's your answer. Not mine. I just teach it. Now, your practice is the same thing. It's 7 problems. I think there's not one like this. I promise. Your cube ones are simpler.